So the last thing I'll show quickly with this is how we can use this to get real-time feedback based on design changes in the building. In this case, I don't have a very intelligent way to change my design. So I'm just going to create a simple function to start deleting some elements of this facade and then visualize what happens. All right, so what I'm going to do is basically just create a logic that takes these lines. Remember, these were all my original members. And I'm just going to have it delete some subset of those lines before I pass them into the structural analysis. To do that, there's kind of an interesting node called random reduce. This is something I do a lot just for like random patterning. Random reduce will take a list of any amount of objects. Here we're passing our lines. Actually, we want to put this after our reduction. Remember, RD lines, we actually got rid of all the duplicates. So we want to do that. So we want to have our final list of lines here. Okay, so we're going to put this into random reduce. And random reduce will take a list and then a number of items to delete, and it will randomly delete that number of items from the list. So in order for us to know how many items we want to delete, I'm actually going to first figure out how many items are in our list. I'm going to use the list length component. I'm going to pass my list into here. This is going to tell me how many items are in my list. So now if I pass all of these items into here, it's going to delete all of my objects, right? Because I passed in 1,290 lines, and I told it to delete 1,290 of them. So it's going to result in 0 objects. Okay, so here I'm going to take this length, and I'm going to multiply it by a kind of factor to be able to dictate how many lines, what proportion of our total lines is reduced from the list. So I'm going to create a multiplication node, and then I'm going to create a slider that goes from 0 to 1 and give it a few significant digits, so 1.00. I'm going to put that into the operator and then put the length into here. So this will allow us to specify the proportion of lines we're getting rid of, okay? And I'm going to put the result into this reduction factor. So if we give it 1, it's going to get rid of all the lines. Here I'll just hide these lines so you can see what's happening. If we give it a factor of 1, it's going to get rid of all the lines. But if we start to scale that back, it's going to bring in just some of those lines. So at 50, at 0.5, it's going to basically keep 50% of those lines. So I'm going to set this to something, kind of a pretty average number, maybe something like 0.4. And now I'm going to pass that result into our lines for our beams. So instead of calculating all the full mesh, it's going to just use this random reduction of lines to calculate the structure. Obviously, this is a structure that's not as good, but it's lighter. So I'm going to try to just see if I can get some feedback about my structural performance relative to my the number of elements. So you can see here already, there's we're getting some feedback. There's a lot of moments. There's a lot more force or stress happening in the elements. Here we can visualize that in terms of displacement, so which objects are moving more or less. And then we can also visualize in terms of deformation. I'm going to reduce some of my forces so we can visualize this better. So I'm going to reduce the wind load and our gravity. So here you can see the deformation that's happening from our revised structural model. And then I'm just going to go through a variety of different options with this reduce. Because this is a random function, it's driven by the seed value, so to get different iterations of the randomness at the same factor, you can just start to cycle through a bunch of seeds. So seeds are always integer numbers, and they can be pretty much any number. This will just give us a different iteration of the random. So as we scrub through here, we see different performances. Sometimes the whole model disappears completely, and that's where the model isn't interconnected. So if we go to one of these values, see there's no model here. If we go to our analysis node, it's going to say that the singular stiffness matrix cannot solve. And that's because our model isn't completely interconnected, so there's pieces of it that aren't attached to supports and are flying out, and it basically becomes unsolvable. If we visualize our lines, you'd be able to find a moment where something's not connected. So here, these lines aren't connected to our model, so it breaks the whole analysis. So you gotta be careful for that. Okay. And then we can also try to see what happens if we have more or less reduction in our elements. So here we're going more towards a full mesh, we have better performance. And going more towards a reduced mesh, we have worse and worse performance. So you can see how real time this feedback is, and this is really useful because you can get pretty much instantaneous structural feedback once you set this up that you can use to make decisions in your design. Once you apply the point loads to your model, you can actually visualize the loads themselves as vectors, and that's all done in model view. So you see here, if we click on model view, it's going to give us our deformed mesh. It's going to give you the supports. It's also going to give you this vector visualization for each load vector. So this is a way you can start to visualize like all the forces that are applied to your model.